Thank you very much. We have one short session before we go to lunch. While we are talking here about all those issues, in the cellar there is something that we call cyber challenge, and that is a kind of competition in which a group of young people try to break some puzzle using some hacking technology. And we'll see a short video describing this before we go to the next session. Please.
Hello, citizen of the world. We are the Illuminated. Today a new dawn is starting. We are going to take over this planet for the best of all mankind. You have two choices: join us, or you will be specks of dust of human history. We are the shadows that follow you and grow amongst you. For years and years we planned and got ready for this day. We already taken control of the UN, governments, and all the entertainment industry. You can't defeat us, so don't even try. Any action against us will be treated swift and with no mercy. We are the Illuminated. One world, one government, new order.
Hello everybody, and welcome to the Israeli Cyber Challenge, conducted here at the Tel Aviv University. This is a hacking challenge, capital the flag type of a challenge. It was developed by the OFIC unit at the Air Force. Guys, here are the guys, and their team developed this challenge. Guys, say hi to the camera. As you can see, we have 19 groups here, different ages, different backgrounds. They all came here to fight each other and try to solve this amazing challenge, the Israeli Cyber Challenge of 2015.
Hi, my name is Guy Mizrahi and I'm a hacker. We founded the Cyber Challenge last year. This year supposed to be better. As a hacker, I'm very excited to see this happening and waiting to see who will win.
So what do we have here? We have the leaders board. On this part of the board, we can see the different teams and their points that they've earned. The winning team will be the one that actually earned as many points as they can. And this time, we have 5 hours and 13 minutes till the end of this event. Who will be the winner? Who will be happy? And who will cry? We'll see soon enough.
So the importance of this cyber challenge is much like other challenges that we see around the world, is gathering groups of professionals, hackers that try to beat each other. This is an excellent tool for us to encourage younger people to take part in this community, to get to know each other better, because collaboration is key for defending against cyber threats in this world, and also exposing them to the industry. So this is a great place for companies to come and see the future of hackers and researchers that do the best job in the world, and the winners obviously get all the credit.
Wow, we had so much fun. Thank you, and we'll see you next year.
Okay. Cyber Challenge was sponsored, and even more than this, was designed by one of the computer units of the IDF, the Air Force, called OFIC. OFIC in Hebrew means horizon, something like this, and also IAI. And the next and last, and perhaps, to my opinion, one of the most interesting sessions that we are going to have in this conference, at this hall, will be on machine learning, or the interface between brain and artificial intelligence, that is computers. For this, I would like to call the one who will manage this session, Professor Nathan Intrator, who is a member of the computer science school here, and also the neuroscience school, and also a member of ICRC. Nathan, please.
Hi everyone. next two speakers, Professor Wolf and Dr. Margalit, are going to speak about artificial intelligence, machine learning, and deep learning, and cognitive learning. So I'll talk about the brain. If I can have my slides, it's number 83. So I'll tell you a few things about the brain, very short, with good news and bad news. So I'll try to explain why brain and cyber are actually connected. Can I have the next slide? Can I do it here? So for those of you who are seeing this slide for the first time, don't worry, we still don't understand this slide. And the whole idea is that I have good news and bad news. Let's start with the bad news. The bad news is that for 70 years of very intense research into how the brain works, we still are not in agreement about the most fundamental fact, and this is the change in a single synapse of a single neuron. Next, please. So we have, that's it. We have 100 billion such neurons in the brain. Each neuron has 10,000 synapses. And for 70 years, after several awards, we still are very far from agreeing on this very fundamental question. What is the mathematical formulation of a single synapse? This is the bad news. So let's go to the good news. The good news is that it is possible to monitor and read brain activity without exactly understanding what it is doing. So in 1985, yeah, I know it sounds a little difficult to grasp. Let me try to explain. In 1985, the functional MRI was invented, an amazing invention, which tells you roughly about every 3 seconds how much oxygenated blood is arriving to different parts of your brain, and it's doing it in quite a good accuracy of 1 millimeter cube. This is quite primitive, isn't it? It's only telling you how much oxygenated blood is arriving at a certain region in your brain. But the amazing result is that out of this information, a lot of stuff could develop, and thousands of papers about different regions in the brain, their relation to specific diseases, specific abnormalities could be developed. And again, I'm not talking about the MRI, I'm talking about the functional MRI, which actually checks our brain activity during activity, so as opposed to anesthetized people. And I see that we went already to the next slide, which is the one before last. And the good news, the further good news, is that now we are trying to develop something like a functional MRI, which obviously was not mobile, as you could see from the picture. We try now to read the brain in a more mobile and much simpler way. So you can see the person on the left sitting in front of a computer screen. This happened 2 weeks ago at a Mindset conference in Yerucham, where there was a hackathon, and we developed material for teaching with the Matach, Merkaz Technologia Chinuchit here. And I just chose to show two slides from that. So what we see here now is a new representation of brain activity. Each column is certain summary of brain activity at a certain second, and we progress once every second. So the x-axis is actually time. And what we see here is two people performing one of Matach's learning tasks. The arrow on the left is indicating reading. That first part in that slide is reading text. Then there's a very long time where the person reported that he was totally bored with the task, and then starts a new task, and you can see at the right arrow on the top slide. you can see the writer on the top slide that activity in terms of at least color becomes much stronger. So the more color, the more towards red or hot, the more activity there is in different functional brain regions. So each line is representing one functional brain network. That part that is very hot or very red in the top slide indicates happiness. That's around an area that represents happiness. Let's look at what happened with the second person. That was a child. As you can see, he was much more concentrated until the first arrow on the left. If you notice that during that first arrow on the left, something was said. Everybody was watching them because we could see that live on this computer screen, and we were excited about it. So someone said something which made him more amused. You can see that he's kind of happier from that point on, but lost attention. You can see that the activity is much reduced in terms of his concentration. So this is the kind of things that we are trying to look into now. Last slide, please. And the connection between being able to read the brain in a mobile and very simple way and cybersecurity is vast. I just gave one simple example. Your imagination can take you anywhere you want in terms of being able to read the brain. The conversation we had just before this session could benefit from reading the brain as well. So thank you for this. And let me invite the first speaker. First speaker is going to be Professor Lior Wolf, who is a faculty member at the School of Computer Science at Tel Aviv University. He was a student of Amnon Shashua and a postdoc with Tommy Poggio, both very prominent people in machine learning and computer vision. Professor Wolf was awarded the 2008 Sackler Career Development Chair, the Colton Excellence Fellowship for New Faculty, and other awards. Professor Wolf's research focuses on computer vision and applications to machine learning and includes topics such as face identification, document analysis, and so forth. Professor Wolf, please.